Piecewise defined functions. The functions in the following four examples are defined by different formulas in different parts of their domains. For example 7, we're graphing a piecewise defined function. A function f is defined by the following. We're going to say that f of x is equal to 1 minus x if x is less than or equal to 1. And then f of x is equal to x squared if x is greater than 1. So here are the restrictions. So we want to be able to evaluate f of 0, f of 1, and f of 2, and then sketch the graph. So for the first one, we want to find f of 0. Okay, so that's telling us that when x is equal to 0. So if we take a look at our function up here, okay, wherever 0 falls within that domain, then we're going to use that equation. So where does x equal 0? Now, is 0 greater than 1? The answer is no. So it can't be using the second equation. The first equation tells us that 0 is less than or equal to 1. So because we know that 0 is less than or equal to 1, then we're going to use the first equation, which is 1 minus x. So we're going to take 1 minus x and then plug in x to be 0. So 1 minus 0 is going to equal 1. Number 2, we're going to find f of 1. So that tells us that our input x is equal to 1. So if we take a look over here now, is 1 greater than 1? Well, that's false because it has to be equal to. You can't say that 1 is greater than 1 because they're equal to the same thing. So here we know that 1 falls within the domain of less than or equal to 1. So we're going to use the first equation, 1 minus x. So we have 1 minus x. And substituting 1 in for x, we get 1 minus 1, which is equal to 0. Okay, number 3, we want to find f of 2. So which domain does 2 fall in? Well, we know that 2 is not less than or equal to 1. We know that 2 is greater than 1. So again, using the input x equals 2, we know that 2 is greater than 1. So we're going to use x squared. So using x squared, we're going to plug in 2 for x. And when we square that, we get 4. Okay, the last part is we need to be able to sketch the graph. So we have two equations. Okay, the first equation we'll call it A, and that is 1 minus x. And then our second equation is B, which is x squared. Okay, so we know that 1 minus x is our equation. Okay, and we're going to set that equal to y. So that means if we rewrite this as y, which is equal to negative x plus 1, we can determine that the slope is negative 1 over 1, and the y-intercept is 0, 1. So we can graph that. So that means when we graph this, we know that we have, let's see here, we'll graph this, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so we're first going to draw our y-intercept, which is 0, 1. Okay, and then what does our slope tell us to do? Go down 1 and then to the right 1. Down 1 and to the right 1. Down 1 and to the right 1. Down 1 to the right 1. And the same thing, we're going to go up 1 to the left 1. Up 1 to the left 1. Up 1 to the left 1. So if we look at this graph, let's connect this here. There's our graph. Now, let's also graph y equals x squared. Well, this is going to give us a parabola. Right, so we know that when x is 1, we know that the y value is 1. When x was negative 1, the y value was 1. When x was 2, the y value was 4. When x was negative 2, the y value was 4. So let's go ahead and graph that, and that gives us our parabola. And let me put those points in a little clearer. Okay, now, but we need to put in these restrictions, and those restrictions are important. So what it's saying here is that 1 minus x if x is less than or equal to 1. So we have to erase everything that is greater than 1. So if we take a look here, we need to erase here everything that's greater than 1. And what is greater than 1? Well, we know that everything that's greater than 1 is from here on out. Now, we know that it has to be less than or equal to. So if it's less than or equal to, we know that we can include that point. So what am I going to do? Well, I don't need any of these other points. This is all I need. I need this part here. And therefore, this is part of my piecewise defined function. So what does that mean? That means that I should have a graph here with a solid dot and a line going in that direction. Next, we want to take a look at the other one. So the other one says it has to be greater than 1. So it can't be equal to 1. So wherever it is 1, we're going to have to erase everywhere else. So we don't need that part because it's got to be greater than 1. We can't use that, and it's got to be at 1. So it's at 1, but it doesn't equal 1. So that dot should not be a closed dot. That dot should actually be an open dot. So this graph is going to have an open dot here, and then that one. So that's the two pieces that we graph. Now we got to put them together on a graph, and you can see this is what we have here. Okay, this first function represents f of x, which is equal to 1 minus x, where we know that x is less than or equal to 1. And then on this side, we know that this is f of x, which is equal to x squared, where we know that x is greater than 1.